Like here I talked about binomial expression, and by definition I said binomial expression is an expression that is connected by a positive or negative sign. For example, we have p plus q, we have 2a plus y raised to 4, and we have a minus x raised to 6. We may have a plus x also raised to 5. These are the examples of binomial expression. And then now let me go to Pascal triangle. And Pascal triangle is triangle which expresses coefficients of terms of binomial expression. This binomial expression. For instance, let me give you an example. We may have a plus x raised to 4. So in a Pascal triangle, it can take a shape of a triangle having coefficients only. And we have this one example. So we start solution. So we start from a plus x raised to 0. We have a plus x raised to 1. We have a plus x raised to 2. We have a plus x this is a plus x raised to 3, and then a plus x raised to 4. So in Pascal triangle, when you see an expression raised to 0 or any number raised to 0 as an index is 0, this is 1. When you see this raised to 1, know that you have two terms of coefficient, and know that the first term should always be 1 and the last term should always be 1. Those are the coefficients. So here when you say this 1, so we have 2, so you should know if it's 1 you have 2. So we have 1 and 1, the first expression, the first coefficient and the last coefficient. Then if you say 2 raised to 2, you should have 3 terms. So 1 dash 1 to make 3. So 1, this is the first coefficient, and the second one in the middle, and the last one, which is should always be 1. And here we will come back to 10. If you see this raised to 3 also, you should have 4 terms. So this is 1, 2, 3, 4. If you see this raised to 4, you should have 5. So 1, 2, 3, 4, 5. 5 is the last one. So let's now come back to filling the Pascal triangle. So this is 1, this is 2. So to fill in the middle here, so we add the previous coefficients. So we have 1 plus 1, to make 2. 1 plus 1 to make 2, so this is 2. So this is 2 here. So to fill here, so you have 1 from the previous coefficient. So 1 plus 2 here, 1 plus 2. So we have 3. Then we have 2 plus 1. We have also 3. And then here we have 1 plus 3. We have 4. 3 plus 3. We have 6. Then 3 plus 1. We have 4. So this is the final coefficient or coefficients of a term a plus x raised to 4. So these are the coefficients. So let us now do an example for the full binomial expression having a plus x raised to 4. So as earlier I said, a index of a here should be decreasing towards right, and index of x here should be also decreasing towards left. Here I mean it should be a raised to 4, a raised to 3, a raised to 2, and a raised to 1. So it is decreasing towards right. But x, the end is x raised to 4, here is x raised to 3, here is x raised to 2. But we have coefficients here, so it is decreasing towards left. So now we have a plus x raised to a plus x raised to 4. So now let's do the expansion, and you say a should be decreasing towards right, and earlier we had the coefficient of a raised to 4 as we started. So we start with 1, which is 1, and then we had 1 also. So this is the coefficients, and then we had, let me start here, 1, then we had 1, came back to, this was raised to 4, this is raised to 0, raised to 1, we have 2, raised to 3, we have raised to 2, this raised to 1, raised to 2, we have 3, raised to, we have 4, then the last one raised to, we had 5, 1 2 3 4 5, 2 3 4 5. So this was 2, and then this was 3, this was 4, 6, 4. So this is the last coefficient, and I said last one here should be 1. So we can now substitute this Pascal triangle. So the last one we should have here, so it should be 1, which is 1 coefficient, raised to a raised to 4 plus 4 here, this one, this is a 4, a raised to 3 but x raised to 1 plus 6 a raised to 2 x raised to 2 plus 4 x raised to 3, 4, this was 2, no, not x, 4, a raised to 1, but x raised to 3. Let me simplify here. So we have 4, a raised to 1, or let me leave it, and x raised to 3. Then plus the last one is 1, so I can say 1 x raised to 4. So as you see, 4 is decreasing, the value of a decreasing towards right, while the value of x is increasing towards left. As you see, x is 4, and then we have x3 towards left, x is 2 towards left also. So that is it. Let me try another one of a plus y raised to 3. So using Pascal triangle, so answer a. So let me do it here so that I can do complete somewhere. So you have 1. Let me do it here. So you have a raised to y raised to 0, a raised to y raised to 1, a raised to a plus not raised plus y raised to 2, a plus y raised to 3. So here you have 1. We have 1, 1. So I told you when you see an index of 1, you should have two coefficients, or 2 terms of coefficients. If you see 2 raised to 2, you should have 3. But the first one should be 1. The last one should be 1 also. Out of the 3, so you should have a dash that we will come and fill, or we can just add right now from the previous. We sum up from the previous coefficient. So 1 plus 1 is 2, and then here we should have 4. So 1 plus 1, and then the second place of coefficient. So we sum the previous coefficients. So 1 plus 2 should be 3, and then here 2 plus 1 should be 3. Then the last one 1. So this is the final answer of coefficients of a plus 1, a plus 5 raised to 3. So let me do it here. So we have 1, and then here we have a raised to 3, then a raised to 3. We have which should be 1 also, should be a, and then the last one is a raised to 4, a raised to 3, just stick a thing here, a raised to 3 plus 3, a raised to 2 plus 3, a raised to 1, but we should have x also here. Then we have here x, and y, we had y here, so that is fine, and then y, then we have the last one should be plus y raised to 3, so y 2, then y 1 here, we have no y here, so it should be a raised to 3, a raised to 3 plus 3ay 2. Okay, let me do it fresh. We have a raised to 3 plus 3a raised to 2y plus a, then y2 plus y3. So coefficient y here it should be 0, y raised to 0, which is 1. Then it is decreasing. A coefficient of a is decreasing towards right. 3, 2, 1. This is 3. And then here we have a raised to 2 plus 2a raised, yeah, this 1, and then plus y raised to 2. Here we have y1, decreasing towards right and decreasing towards left. And here we have a plus y. When we have 1, it should remain like that, like a plus 1, and then any number raised to 0 should get 1. So this is a complete Pascal triangle. The first one, a plus y raised to 0 should get 1. The second one, a plus y raised to 1, remain the same, a plus y here. Then the second one is a quadratic, it's a squared. So a plus y squared. So it should be a square plus 2ay plus y square. Yeah. Or shortcut whereby we say the first one should be a squared, the last should be y squared, and then in the middle, the number in the middle is the sum of the two terms. You double 2ay, which is raised to 1 which is the same as the third one is this one. We had coefficient, so wait.